So welcome back. Sorry it's been a while since I've uploaded a video. I think everyone knows that the world's been a bit of a crazy place, and I have just been swamped with work, most of which I can't show you on YouTube here, so I really haven't been posting a lot. For those of you who don't know, I operate what I'll call my machine shop down here. I've gotten a bunch of questions on what my basement shop looks like, so I'll give you a quick walk around today. Most of what I machine is firearms parts. I do some knives and then some odds and ends for friends and for personal use. So not a full production machine shop by any stretch of the imagination. I work out of my basement, and I use this Precision Matthews PM-30 that you see in front of you here. I did convert this to CNC myself. It did start as a manual machine. It's had some pretty extensive upgrades that I plan to go through with you all in the upcoming weeks, and I have quite a substantial upgrade planned for the mill that I'm going to walk through with you too. So stick around. It's going to sort of just be a single take, maybe a 20-minute video of walking around the shop and talking about some of the plans I have. So I apologize, you're on a tripod now, but I'll be walking around by hand. So if it's not the steadiest of views, I apologize. So real quickly, this is my Precision Matthews, words are hard, PM-30MV. I currently have it outfitted with 2 import 5-inch vices. That's worked great. I have a huge upgrade coming in that department. I'm getting 2 dual station vices from the guys over at M-Lock. So those are in production right now. He has sent me some videos and pictures. Awesome company to work with so far, and I'll give you an update when I get those. So the mill vices are both going to go, and then I'll retrofit those somewhere else, and I have a huge upgrade there. So I'll have 4 stations with the 2 vices in a smaller footprint and a larger work capacity than I have now, which is awesome. I'll talk about the upgrade in a minute, but for now I'll just do a quick walk through the shop. So as you can see, I've been cutting quite a bit of aluminum. That chip pan here gets filled up pretty quickly. I've been using Linux CNC, still extremely happy with that. So I would definitely recommend it. I do plan on upgrading to a Probe Basic version of Linux CNC in the near future. It's in beta testing right now. I may end up testing myself after I do the upgrade, so I'll talk to you about that. Just a quick look around. So I do have my washer and dryer right here. This is where I store a lot of my unused tooling, some of my tooling that's set up but not in use. And then in these drawers here is where I store a lot of my in-use tooling. I do have some new tools. So this is a Shear Hog, the 3/4 inch version from AB Tools. This is an incredible tool for cutting aluminum. And then if I walk around over to here, if you haven't seen one of these before, these microscopes are extremely valuable and definitely worth the price. They're not expensive. I'd say less than $100, and they do magnify pretty well. So I'll just show you real quick. If you're using end mills that are less than 1/8 of an inch, this is a 0.098 inch thread mill that I use for 632 screw holes on firearms. Good luck seeing that with the naked eye if you have a chipped flute. Sorry, I'm going to make somebody nauseous here. There. But get this in focus here. There we go. And I'll try zooming you in. This is, like I said, well worth it. And this is not at the lowest or the highest magnification. Actually raise that. And there you go. So you can see, good luck seeing those 4 tiny little flutes with your bare eyes. So I would definitely recommend picking one of these up if you're in the market for some sort of microscope. Coming over around here, aside from the laundry equipment here, this is where I do a lot of my prep for Cerakote. So this is just a little tub from Amazon that works great for an acetone bath. I have a little photo booth over here that I also got off Amazon with an infinitely adjustable LED light in there. You can change those background colors. Works great to take pictures of firearms and my other small projects. and then I usually use this for racking. That's a slide cover plate that I've been working on. Down here, so this, I used to make Kydex holsters, things like that. It's actually what this down here is for. It's some presses for Kydex holsters. Up in the shelf here, these are a couple 2-foot by 4-foot sheets of black Kydex. I probably have a dozen sheets left of black, a bunch of carbon fiber and some smaller pieces. Down here, I keep some packing materials. That's the Home Depot acetone that I get. Works great for degreasing parts, things like that. A little sander. I have to upgrade the spindle light on my mill, burnt out, so I have to replace that. This will become the motor, and I have the drive somewhere for a 4th axis that I have planned for the mill. Coming into here, if I did have a big enough YouTube channel, this would definitely be a demonetization zone here. So here are some personal firearms of mine. These are some that I have slated for work on. Organization is pretty big to me, so I have a bit of OCD, and I like to quote unquote bin things both in my mind and in real life. These are set apart by customer and things like that. So I've shipped out about a dozen slides this week, and here's another 8 or 10 ready to go or ready to mill in the next couple of days. Reloading that Lee progressive press is super cheap and very, very valuable. I've probably loaded 60, 70,000 rounds on this. Replaced just about every part in it because it's definitely breaks more often than something like a Dillon, but for the price, you definitely can't beat it. So this is my little prep and reloading room. And then I guess to go into the toolbox a little more, I have some of the smaller sets of gauge pins. Most of them aren't even open yet. I only open them as I use them. So that goes up to 1/4 inch for gauge pins. I have a set of gauge blocks here that I use quite often as well. And these, again, not the greatest. They are grade 3, but they work great for what I'm doing. I mean, this PM30 won't hold tenths anyway, so I don't need accuracy of metrology equipment that does that. Typical rule of thumb is to try to get equipment that is 10 times more accurate than the machine you're working on, and even a grade 3 gauge block is going to meet that. I use a lot of these SHARs and eye gauging digital micrometers. They work great. I have some Starretts, another import caliper. I do have a few Mitutoyo test instruments. So this is a small 4-inch dial caliper. And I mean, there's definitely a degree of quality that comes with a Mitutoyo, but for the work that I do, it is not worth investing in a full set of Mitutoyo everything because I just don't use it often and need it that accurate. You've probably seen some really awkward setups before. This is my 3-jaw chuck that I built a riser block for to bolt to the mill. Sometimes I just hold that directly in a mill vise, and it works pretty great for holding round parts in the mill. And then to pan over to here, I guess we'll get to all that in a minute. That's really the reason I am making the video today. If you haven't seen the last few videos I've uploaded, I did recently purchase this 50 watt fiber laser. It is a Chinese import that I got from a US distributor on eBay, and I was very happy with that purchase experience. So this laser engraver has been doing awesome work for me. I mean, it does great work in aluminum, just on anodized finishes, or in, making deep marks. Some of these are over an 1/8 inch deep in aluminum or tool steels. So I definitely recommend this if you need to mark metals and even some plastics. I'll do probably a lot more videos of this as the months go on. But so to get in, and I'm going to set you down now, to get into sort of the meat of why I am making this video today, I'm looking for some feedback from everybody on how you'd like me to film this project, and just to give you an update of where I'm headed. So to go over it, I have had for a long time plans to upgrade the milling spindle, or the spindle motor, I should say, on the Precision Matthews PM-30. I'll go back over real quick and see what we have on there. This 2 horsepower brushless DC motor that's mounted on the mill right here, that comes stock with it. just does not have enough torque or power after a CNC conversion. The speed that you can move manual hand wheels is extremely limited, especially with any degree of accuracy. So having really high spindle horsepower on a manual machine is just not needed, which is why they'd elected to go with this smaller 2 horsepower brushless DC motor. It's a large reason why you'll see what people used to call very large Bridgeport knee-type mills with only a 1.5 horsepower motor on it, because it just didn't need anything more than that. So I've run into a lot of instances I mostly cut tool steels and high carbon steels where I've just been limited at the amount of torque and power that spindle motor has. So that's where this comes in. Everything worth doing is worth overdoing, a quote I like to say. So that is what I did here. If you look over in the corner here, that is a 5 horsepower 3-phase induction motor from Marathon Motors. The model number is a Y1372. That motor is going to eventually replace the spindle motor on the Precision Matthews. If you for the keen observer in you, have noticed the size difference from the motor I just showed you to this guy here. It is astounding. So I'll put my hand up against it. This is a 9-inch diameter motor, so the outer can of it is 9 inches. Once you take into account the fan shroud, it's about 9.25 inches. It has an 1.125 shaft on it, and it's just beefy. I mean, it is way oversized for the application that I have, and that's really been the intent for me for quite some time. I would rather have the rigidity of the machine, the rapids and the feed rate be the limiting component and not the spindle. If I had it my way, there would be plenty of reserve horsepower in the mill at all times, and I would start breaking tools before I started pushing the limits of the motor, and that's really what I'm aiming to achieve here. So that motor will spin 1760 is the base horsepower for it, so it's an 1800 RPM motor. It will run at constant torque from essentially 0 RPM, a little bit above that for my needs, I'll call it 0, up to 1760 RPM. And then from 1760 to double that, so about 3600, just shy of 3600 RPM, it will run at constant horsepower. So I'll have that constant 5 horsepower. The bearing motor, or the motor bearings in this motor, are rated to 4000 RPM. I do not plan on pushing it to that, so I'd like to operate it all the way up to that constant horsepower range and no further. So obviously 3600 RPM is not enough for using small tooling. The PM30 currently only has 3,000 RPM available to it, and that's another huge disappointment for a CNC mill, is a lack of spindle speed. So I'm going to tackle 2 birds with 1 stone with this project. The 5 horsepower motor at 3,600 RPM, if you double that and you ran it at 7,200 RPM, then sorry to clarify, if you ran it at 7,200 RPM through gearing or belts, then you would just half the amount of horsepower that you have available to you. So even if I doubled the speed of this motor through a belt system and had the spindle running at twice the speed of the motor, I would still have 2.5 horsepower on a 3-phase induction motor, which is going to have way more torque and way more power than the 2 horsepower brushless DC motor that's on the mill. So for the time being, the spindle bearings on the PM30 are only rated to 5,000 RPM. So if you were to spin this greater than 5,000 RPM without replacing those, then eventually you would damage these spindle bearings, wear them out, and you would likely start getting some run out issues, overheating, things like that. So for now, just because I don't need to tackle every project in my mind all at once, I am going to limit the top speed of this machine to 5,000 RPM, and I'm going to do that just by belting it at about a 1.4 to 1 ratio. So at 3,600 RPM on the motor, I'll be running about 5,000 RPM on the spindle, and that'll leave me with just over 3.5, I think, horsepower, which is going to be so much better. Almost double the speed and over double the torque in a motor is tremendous for a machine like this. So that's the plan. Now to get into a bit of what else is on the floor here. So this VFD, that's a Delta MS300. That is actually a 10 horsepower VFD. Rating VFDs in horsepower is one of the most useless things you can do because that doesn't really mean a whole heck of a lot. The more important rating is the output current or the amperage rating on a variable frequency drive. So the reason that I went with a 10 horsepower VFD is because this is a 5 horsepower 3-phase motor, and if you've ever done some research on VFDs, it's difficult, if not impossible, to find a single phase to 3-phase, so single phase input to 3-phase output VFD rated over 3 horsepower. They just don't really make them. I'm not going to go into an electrical engineering discussion of how a VFD works, although I do have an electrical engineering degree that's a bit over the bounds of this video for now. But basically all it does is it takes the input voltage you're giving it, converts that to DC on a DC bus, and then it through sort of, I'll say, pulse width modulation, so gating IG bits on and off, it will convert that DC bus to your simulated 3-phase output. So it really doesn't care if you give it 2 of those 3 legs or even 1 of those 3 legs of input power. All it's going to do is try to meet your output demand by raising the input current. So like I said before, the more important rating of a VFD is the input current, or sorry, the output current that it's able to produce, and not so much the horsepower rating on it. So in order to get a VFD that could supply 5 horsepower motor on single phase input, I needed to jump up to this larger circuitry so that the internal components could handle the higher input current with a 5 horsepower 3-phase output. I rambled a bit there, and I'm sorry if I lost everybody for a minute, so I'll stop kind of going into the specifics there. What I'm waiting on for the control side is I need the enclosure, which I've ordered. I need a magnetic contactor, which is going to isolate power in the input. I need some fuses and some ferrites for the output to filter out some EMI. So all of that is on order and should be here within the week. With everything that's been going on with the COVID-19 outbreak, shipping for basically everybody has been delayed. That's obviously not a complaint. There's bigger things in the world than me getting my VFD running. So that's just something I have to take into account. Once those components come in, I'll have everything I need for the VFD. Down here, this plate of aluminum, 1/2-inch thick plate of aluminum, is going to be used for the motor mount for that. So it'll it'll bolt to the base. This, I'll get into that in a second. I'm going to cut this into 2 pieces, and those will basically be frame rails that the motor mount will ride on so that you can slide the whole motor back and tension the belt. I am going to use a timing belt system and pulleys so that I have basically synchronous speed and I don't have any slip in the belt. So you do need to tension those, not a great deal of tension, but you will need some play in the radial direction to make sure you can push the belt taut. So that's what this is going to be. Like I said, I'll get to that in a minute. This motor weighs about 70 pounds. The old motor only weighs about, I'll say, 25. So I am going to be putting significant amount of weight on top of the head, including, I guess I'll just talk about this real quick. That's a 2.5 inch thick piece of aluminum. So unfortunately, the space that I have available, again, sorry if I'm making anyone nauseous, the space I have available between the saddle or the dovetail of the Z-axis, right back, see if I can get you zoomed in. The space I have available between this Y this Z dovetail face, and where I need to access the drawbar, right now is only about 7.5 inches. So I need to put a 9-inch diameter motor in this space where there's only about 7.5 inches right now. Obviously you don't need to have, any sort of engineering degree to know that doesn't work. So another problem that's plagued me for quite some time, has been the distance between the center line of the spindle and the back Z column of the mill. So when I converted the machine to CNC, I took a little bit of the casting out of the Y-axis. So I cut a chunk out of the casting, which I actually have right here. So I cut this out, allowing me to travel in the Y direction, the thickness of this or the width of this more. So it's about 2.5 inches that I removed, which means the Y-axis can travel toward us 2.5 inches more than it could from the factory. So I do have about 9.5 total inches of Y travel. Unfortunately, because I didn't move the center line of this spindle out 2.5 inches with it, it means that when the table is all the way toward us, I can't reach the last about 2 inches of the part. So I'm hanging way over on this side of the mill, and then if I tried to move the table as far as I could in the Y direction, like that, it means I run out of travel, and even though I could have maybe a 7-inch part in here, that part would come to here, and I would not be able to reach it with the spindle. So I have all that extra travel, and it's essentially been useless. My plan to fix, two birds with one stone here, is this is the saddle that the Z rides on. Between that saddle and the head, these are two separate components, I'm going to put that Z spacer that I'm going to make out of that block of aluminum. So I'll move this whole head portion about 2.5 inches closer, meaning I'll have the full use of my Y travel, as well as have room between the dovetail and the spindle, to mount the new motor. So that is the plan here. Lastly, the final upgrade that I plan on doing is after I add all of that extra weight to the Z column, all that extra horsepower to the machine, and all the extra bells and whistles for 5,000 RPM, it really doesn't do me much good if the machine starts to crumble under its own weight and doesn't have the rigidity to support any of that. So in these two 5-gallon buckets, I have a lot of, it's about 100 pounds of a polymer concrete, or some people might call it epoxy granite, from Castanite. I plan on filling the entirety of the base as well as most of the Z column with this epoxy granite. So that will give me a lot of stiffness, some rigidity in the machine, vibration dampening, all those keywords and tricky phrases for good things you can do for a CNC mill. So that will be a huge undertaking, but very well worth it at about 100 pounds and a lot of vibration dampening. Whatever I can't fit in the mill, the excess will just go in the manufactured base that I made for this mill. So all of that will end up getting added to the machine somewhere. Lastly, what you see down here, those are two 100-pound each air struts. So with the added weight to the Z column, when you pile up the plate that's going on the base of the motor, the chunks of aluminum for the guideways, the spacer, and the 70-pound motor, the Z-axis motor would be doing a lot of work, and it really wouldn't like it. I did test it, so in my less dad bod days, I did actually used to use this gym equipment, but conveniently enough, I have plenty of weights sitting around. I added 90 pounds worth of weight to the Z-axis just by adding weights to it, and then ran it at full rapids up and down, and it didn't sound like it liked it, but it did it. So it would work if I left it how it is, but I would definitely prematurely wear out that motor, and I would probably induce a heck of a lot more backlash in the Z. So that's not something I wanted to do. I'm going to build a counterbalance system with these and hopefully perfectly balance that Z so I can get plenty of speed and float that head so I'm not inducing all that weight on the column and bowing it. So there you have it. That's the plan for upgrades on the Precision Matthews PM30. If this is something you guys would like to see, then please drop me a comment below. I have a couple questions for you viewers out there, if there is anyone watching this video. Would you rather see all of this that I just discussed performed in one video? Have me, next 2 months, I'll say, work on all this, film it as I go, and compile it into one long video where I can't really give you a lot of detail on everything, but you can see the full project start to finish in one sitting? Or would you rather me film it as I go? So the first step is probably going to be getting the electronics all mounted into an enclosure, getting the VFD powered up and setting all the settings up. Second step would probably be getting the motor turning, just sitting on the floor right there and seeing if I have speed regulation, and then along the way I'll be milling these components in the current setup, getting them prepared so I can put everything together, and then lastly, I have gotten dozens of comments asking me to do some sort of video on how I converted the machine, so I do plan on doing that. I think I will probably film it being taken apart as I do that, and then as I modify things, I'll film that, and then film me entirely putting it back together as if I was converting it for the first time, for those of you that would be interested in that. So that's really all I had for you today. This is getting pretty long, almost 30 minutes now. So if you stuck around, I appreciate it. And drop a comment below if you'd like me to, film this as I go and give you, I don't want to say a weekly installment, but probably a bi-weekly installment of my progress and filming what happens. Or do you just want me to shut up and wait a couple months so you can have the gratification of seeing it all in one video? So let me know, and I look forward to hearing from you. Thanks.